Hello everyone, this is Pre-Cal Final Exam Review number 1. I'm going to be working through the problems on this sheet, this section 1 and 2 Fall Final Exam Review. A few of them I'm going to leave for you to work, and those I will just put the answer on there. So this video will probably work about the first 15 of them, something like that. And then I'll end up making probably about 4 different videos for you to watch. Alright, so number 1, we have evaluate, and it's an absolute value equation. So let's plug in, we'd have, since b is 3, we're going to plug in -3, absolute value of -3, minus the absolute value of -5 over -b, so that'd be -3. Absolute value of -3 is just 3. Absolute value of -5 is 5 over -3, so that's going to be -2 over -3, which is 2/3. Alright, number 2 says simplify. And we would have x to the 4th times y cubed times -5 x y cubed all to the 4th. Alright, so of course you'll have your calculator. This is going to be, I'm going to do this parenthesis first. So x to the 4th, y cubed, -5 to the 4th. That's -5 times -5 times -5 times -5. That's going to be 625. X to the 4th. And when you raise a power to another power, you multiply. So 3 times 4, that'd be y to the 12th. Now, when you multiply powers, you add. So I'll put the 625 out front. X to the 4th times x to the 4th. You add there, make that x to the 8th. And then y to the 3rd times y to the 12th would be y to the 15th. All right, so it's really just a matter of remembering when you raise a power to a power, you multiply. And when you multiply 2 powers with exponents, then you just add those exponents. Okay, number 3, we have a fraction here, 4xy to the 5th all squared over 4x all squared. Alright, so 4 squared is 16, x squared, y to the 5th squared would be y to the 10th. And then 4 squared, 16, and then x squared. So the 16s will cancel, the x squareds will cancel, and you're only left with y to the 10th. Number 4, I want you to work that one. So that's some practice for you. The answer to number 4 is a squared over 3b to the 9th. So give that one a try on your own. Pause if you are still writing. All right, let's move to number 5. So number 5 says simplify. And we have 9 to the 4th, x to the -1, y cubed to the -4th over 9 to the 5th, x cubed, y to the 5th to the -5th. Now, what I do on one like this, I go ahead and move the entire parenthesis on the bottom to the top to make it a +5. and the entire one on the top to the bottom to make it a +4. and then I expand. You could go ahead and multiply by negatives and then move them up and down. Either way is fine. I believe my method is just a smidge safer. So we have 9 to the 5th, x cubed, y to the 5th, to the positive 5th. Again, I'm moving this entire parentheses upstairs, and the only thing you change is the outside exponent from negative to positive. And then let's move this guy downstairs. 9 to the 4th, x to the minus 1, y cubed. Now, the exponents, again, inside the parentheses, you don't change their sign. You change only the one that's outside. Now let's expand. That'd be 9 to the 5th times 5 would be 9 to the 25th. X cubed to the 5th would be x to the 15th. Y to the 5th to the 5th would be y to the 25th. 9 to the 4th would be 9 to the 16th. And then we would have x to the minus 4 and y to the 12th. Okay, so what we're going to have here is 9 to the 25th minus 9 to the 16th. So 25 minus 16 would be 9 to the 9th. You don't need to put that in your calculator and give me this huge number. 9 to the 9th is 5. 15, remember, if it's division, you subtract. So 15 minus negative 4 would be x to the 19th. And then 25 minus 12 would be y to the 13th. And that will do the trick. All right, number 6, we want to simplify the square root of 18x to the 5th, y to the 4th, z cubed over 2x. All right, I'm going to raise this all. I'm going to make this to the 1/2 power. I'm going to kind of do two things in one here. So the square root is just the 1/2 power. So 18 over 2 is 9. X to the 5th over x would be x to the 4th. Then we have y to the 4th z cubed. Let's raise all that to the 1/2 power. So that's going to be 9 to the 1/2 power. The square root of 9 is just 3. X, 4 times 1/2 would be x squared. 4 times 1/2 would be y squared. And then z, just leave it as a fractional exponent. It's positive. I let you use fractional exponents. Some math teachers don't. I do. I just need you to make them, if they're negative, I need you to make them positive in the end. Okay, so this is fine for me. Okay, pause it if you need to. All right, number 7. We want to rationalize x over the square root of x minus 4. Now, we have to multiply. We're trying to get the radical out of the denominator. So what we do is multiply by a clever version of 1 to get rid of the radical. And that clever version of 1 is the conjugate. Square root of x plus 4 over the square root of x plus 4. That's just a really fancy version of 1. So that's totally legal. So we would have x times the square root of x plus 4. And then we're going to FOIL the bottom out. Root x times root x is just x. Negative 4 times root x plus positive 4 times root x. Those terms go away, and then you have minus 16. That's fine with me. You can circle that and leave it like that. If you want to do x root x plus 4x over x minus 16, that's also fine. Either way is fine. But let me tell you something very important. This x and this x do not cancel. That negative 16 is attached to that x. You cannot cancel out that x. That is something that you guys did not do. I warned you this year, and I don't know that anyone did it. All right, but people in the past, I've had students that would just cancel out that x and leave that negative 16 there by itself, and it doesn't work that way. Number 8, I want you to work on your own. The answer is negative 9 plus 4 times the square root of 5. All right, so give that one a try. Okay, number 9, turn the page. It says find the domain of x minus 2 over 8x minus x squared. What we're looking for here is where is the denominator 0? All right, where's the denominator 0? It's also a way to find a vertical asymptote, okay? But we have to, the domain of this excludes any number where that makes the denominator 0. So let's just factor an x out of the denominator, and you would have 8 minus x. Set that equal to 0. So x is equal to 0 and 8, right? But what we're saying, all you have to write for me is that x cannot be 0 or 8. If it's 0 or 8, it makes this entire denominator 0, and it's undefined. So this is a shorthand version that you can write for me, and I'm fine with that. Other math teachers will make you write a long sentence out. Number 10, I want you to work on your own. The answer to number 10 is x cannot be negative 3 or negative 4. Okay, pause it if you haven't finished. Let's do number 11. So 11 we want to simplify, and here we're getting into some factoring. And we have x squared plus 4x minus 12 over x squared minus 36. Okay, if what you want to do is factor the top and the bottom. So let's just go ahead and put our parentheses in, make ourselves feel better about that. All right, the top, I think we've got an x and an x, and I need something to give me positive 4 in the middle. I'm thinking a plus 6 minus 2 would do it. All right, FOIL it back out and see if you get that. And then this is the difference of two perfect squares. That's a factoring pattern. X plus 6, x minus 6. All right, you may want to have in your notebook, some sticky notes there, two perfect squares, so you can quickly go to that formula if you need to. All right, the x plus 6 will cancel out, and we have to put a domain restriction here. X cannot equal negative 6 or positive 6 because either of those numbers would make the denominator 0. And then the answer is x minus 2 over x minus 6. I will tell you on the test whether or not to include the domain restriction. On one like this, I would ask you to include it. Pretty simple. All right, number 12. We're going to simplify, and I'm not going to write simplify down. It's on your sheet. X cubed plus 27 over x squared minus 4x minus 21. Okay, this is a special factoring pattern, and I'm going to write them down here, and maybe you put a sticky note in your notebook where these are in case you get one of these. A cubed plus b cubed. That factors into a plus b times a squared minus ab plus b squared. If you know where this is in your notebook, you don't have to memorize it. If you have the difference of two perfect cubes, and again, 27 is a perfect cube, x is a perfect cube. In this case, a is going to equal x, and b is equal to 3 because the cube root of 27 is 3. This factors into a minus b, a squared plus ab plus b squared. All right, so you're going to want to have those handy. Know where they are in your notebook in case you get one of those. So let's factor this. This will factor into x plus 3. And then we would have x squared minus 3x plus b squared is 9. And then on the bottom, this is just your garden variety trinomial. So we'd have x, and then I think minus 7 plus 3 would work. That'd be negative 4. Yeah, that's going to work. And so the x plus 3's cancel out. Our domain restriction, x can't be 7 or negative 3, because that'd make the bottom 0. And then this simplifies into x squared minus 3x plus 9 over x minus 7. All right, pause it if you need to. Let's do number 13. So number 13, oh goodness, this will probably take up the whole whiteboard. Well, maybe not. We have 3x squared plus 7x plus 2 over x squared minus 2x minus 8. Now I'm going to skip a step here just to save some space on the board. See how it's divided here? I'm going to go ahead and flip this second fraction and multiply. So that's going to be times x squared plus 3x plus 2 over x squared minus 3x minus 4. Now we are going to factor. So let's draw parentheses to make ourselves feel accomplished. Okay, here we go. Let's see, I'm thinking a 3x and an x. All right, how about plus 1 plus 2? That'd give me 3x squared plus 7x plus 2. That would do it. All right, here, x, and then somehow I'm thinking a 2 and a 4 would work. So how about minus 4 plus 2? That'd give me negative 2x, negative 8. Okay, x plus 2 plus 1? Yeah, that'd give me 3 in the middle. X. All right, minus 4 plus 1? Okay, that'd give me, yeah, that'd do it. Oh goodness, we got cancellation going right here. Okay, so if I ask for the domain restriction, x could not be, and I might not on this, 4, negative 2, and negative 1. Because those three numbers would make the denominator 0. So what's left here is 3x plus 1 times x plus 2 on top. And on bottom we would have x minus 4 all squared. I'm going to go ahead and FOIL back out the top. That's 3x squared plus 1 plus 7x plus 2 over x minus 4 all squared. All right. Boom. Okay, I can't fit 14 underneath here, so I'm going to go ahead and erase. 14. We want to simplify 3 over x minus 5 plus 2 over x squared minus 25. All right, first of all, let's factor the second one. So that's going to be 3 over x minus 5 plus 2 over the difference of two perfect squares, x plus 5, x minus 5. All right, what we need to get a common denominator. This side is missing x plus 5. So let's multiply this side by x plus 5 over x plus 5. And that'll give us the common denominator that we need. So I would have 3 times x plus 5 over x plus 5 times x minus 5 plus 2 over x plus 5 times x minus 5. Now we have a common denominator, so we can just add the tops. That's going to be 3x plus 15. This one I'm going to go ahead and distribute to 3. So 3x plus 15 plus 2. And then the common denominator, x plus 5 times x minus 5. And then you can just say that's 3x plus 17 over x plus 5 times x minus 5. And there you go. If it said domain restriction, what is the domain restriction? You tell me before I write it. -5 and +5. All right, let's finish up with number 15. This video, it's kind of a long one, and then you can take a little break, right? Or maybe I can take a little break. So 15, we want to simplify 3 over x squared plus 3x minus 18 minus 4 over x squared minus 36. All right, we're just going to factor here. So that's going to be 3 over, this one will factor into x plus 6 minus 3. And then minus 4 over, and that one is the difference of two perfect squares. So x plus 6, x minus 6. Okay, what part of the denominator is this fraction missing? Well, we've got an x plus 6, we've got an x minus 3. It's missing the x minus 6, so let's put it in. X minus 6 over x minus 6. We'll just multiply it by that version of 1. What is this side missing? All right, I'm going to clean this up a little bit. Give myself a little more space. So it's missing the x minus 3. So let's put it in. X minus 3 over x minus 3. So that's going to be 3 times x minus 6 over x minus 6, x plus 6, x minus 3, minus 4 times x minus 3 over x minus 6, x plus 6, x minus 3. Now we have our common denominator, and all we have to do is take care of the top. So the top, distribute to 3, 3x minus 18 minus 4x, and then minus 12. So that'd be plus 12. You've got to be careful with this negative, and make sure that you distribute that negative over the common denominator, x minus 6, x plus 6, x minus 3. And now we just gotta work on the top here. So I'd have 3x, that'd be negative x on top, and then minus 6 over x minus 6, x plus 6, x minus 3. Now here's the thing. If you stop here, you're going to get most of the credit. All right, I'm going to be very pleased. But you can actually do just a smidge more here. That negative x minus 6, if you factor out a negative, it's just x plus 6. Try it. Distribute that negative. It's negative x minus 6. That's the same thing. Now we can cross out that guy, and we're left with just negative 1. So every problem, I believe, is worth 5 points. So I give you 4 out of 5 if you got to here, but if you want to get all 5, then you've got to do this last step, okay? And let's go ahead and FOIL out the bottom there. That's going to be x squared minus 9x plus 18. All right. That's a long one. Would you get, if you got one like this, you would only get 1. I would not give you more than 1 because it takes too much time. If I asked you for the domain restriction, x can't equal 6, negative 6, and 3. Now, I might not ask you one on this kind of question because, you know, you're doing so much work just getting to there. All right, we will pick up with number 16 on the next video, and I will talk to you then.